or one of the two? Aha, so John will do one. Notes, John? Okay, great, JavaScribe, excellent. Sorry, it flashed so quickly I couldn't see. All right, so now we just need notes taker. You can take notes in a text file and email them to me. You can use the crazy collaborative thing on the web if you like. Email's fine. Heasley, excellent, thank you very much. So we have notes taker and JavaScript, so we can start.
We have our obligatory note well. If you haven't read it, you haven't probably been to a meeting yet. So the agenda is not projecting, right? But it's self-describing. So we have a presentation on OpenBMP and a few new proposed work items on BMP again. And finally, Job will present session polling. We have document status. So we inadvertently submitted the large communities usage for publication a little early, but I think it's ready. So we're just waiting for last call to happen, and that'll get submitted. Pretty much all our outstanding documents are now done. So the BGP reject has been submitted. Add paths is in the editor queue. And I guess we do have GShut we think is likely to get resurrected quite shortly. So without further ado, we'll start with OpenBMP presentation. It's Randy and Circle. Duet, all right. As long as it's in tune, so.
Nope, sorry, you have to be in the pink square. Please come to pink square.
Follow me. Hello. He can if he's awake. The problem is this puts us in front of the screen.
Well, there's space for two.
Randy?
Oh, I got to click. Okay, anyway, I'm Randy. We've met before. This is Serpil from Cisco. And over there's Tim. They're kind of users also. They are not implementers. They've implemented OpenBMP, and we're going to tell you a little about it. This is the nutshell. Think about route views and RIS, except for BMP, not BGP. Okay, collector, but they've got a sexy GUI glued on top of it, which lets you do some nice analytics. Okay. And here's some examples. You want to take us through them?
So based on the data we collect through BMP.
I think you probably need to speak a little closer to the mic
Okay.
so everybody in the back can hear and online.
Okay, you can hear me? All right. So through the data we collect using BMP, we can do several visualizations to make it easier for operators to see what kind of a session we've established, what are the enabled capabilities. All of these things we can deduce from the peer up messages that is exchanged through BMP. There are other things we can look at. We can see which prefixes are being updated constantly in the last 15 minutes, which peers they are coming from. We can look at the history of a prefix, how it's been changing, what are the changes are about. I just want to mention these are just a sample set of things we did with the data available. They were very low-hanging fruit that we could immediately visualize and show. But we have access to data that's coming from all the peers that's stored in a database. And there are, in our opinion, unlimited number of use cases you can do, not only on GUI, but also using the APIs to access the data. Here's another screenshot from the demo site where you can look at the peering link, number of prefixes received, and then we do a pre and post comparison, how many prefixes are filtered out. You can incorporate IP geolocation data if you want to. I realize not everybody cares about it. And of course, Randy said the mandatory world map, which is always fun. So these are basically the peers we have been getting the BMP data about from. You can see that there are 7 routers in the screenshot where BMP is enabled, and through that we are able to monitor 733 peers. So the scale is very good. BMP has been available on various vendor platforms. XC has it since 3.12, and it's a simple configuration. XR has it since 5.22. And then Junos has BMP, one of the earlier implementers, since 13.3. After we finished just getting the BMP data, putting in a database and doing some analytics and displaying, one of the things we thought would be really cool is that if you have the OpenBMP software, but you don't have your own BGP feeds, we thought, well, route views and RIPE have been collecting publicly available BGP data and making it available to everyone. It's an MRT formatted data. But what if we just took the MRT formatted BGP data from route views and convert it to BMP and feed it into our system, which basically understands the BMP messages and parses them. So we can see, you know, the best path as seen by route views, and since then we have implemented getting the data from RIPE as well. And then you can do several different types of analysis using the data coming publicly available, including looking at some of your own prefixes and see what they look like on the internet from different peering points that route views or RIPE has. Please.
This one to me is interesting because the dark side of this story is why feed route views into a fake BMP? And that's because you're not giving this project enough BMP feeds. Right? Why do I want BMP is not to see route views. I have lots of tools for that. I want to see what's input and on the input side. Okay? So this is a symptom of a problem. There's another part of the problem, which is why you're not feeding BMP to this. And that's because the implementations are, shall we say, not the best. So why we're here is to try to get feedback about BMP, about open BMP, but also about what we want from BMP from the implementers at the vendors. Okay, and Tim and Serpil and I are users, really. Okay. So I just want to do a side shot, which is while we're early in the BMP process and the Open BMP project, which is a collector like route views and RIS, and probably route views and RIS will also start to be BMP collectors down the pipe, who knows, that we have the problem with route views and RIS that we don't know what kind of feed we are getting, right? Is that feed in route views what you're showing your customer, or what you're showing your peer, or a full internal dump? So there was this draft that said what community, how to tag it with communities to tell the collectors what you're giving them. And I think we might want this before we start scaling collection. We made the mistake in route views and RIS not saying, hey, we only want full feeds, or we only want peer feeds, or we want marked feeds. Yes, Yob, it's another good use of communities. Okay. So are the specs and implementations what we want? Go for it, Yob.
Are you, Job Snyder's NTT, are you sure this is a good use of communities?
I don't know.
Because
We've got plenty of bad uses of communities. Why
There- there-
stop now?
there may be two approaches to this. I could mark what I send you, but then you don't see what I'm not sending you. I cannot use communities to signal what I'm not sending to you.
No. I'd be perfectly happy if there's a web page on the collector that when you first connect to it, you say, this is the kind of feed I'm giving you. Don't care. Let's not go down that. I suggest it's not very interesting. We're not really discussing this draft, right? But I think we need to, before we scale, be BMP collectors. We don't want to repeat the mistake. What hack we do, that's up for grabs, right? Okay, are the specs and implementations what we want? And I think not, and you'll get that in the next two. What we really want is more data, and so, you know, this is kind of a Venn diagram of it, and you're giving me the wrong slide. I'm going to get in trouble with Lucy. This is the wrong slide. There's a missing slide.
These are the slides you sent us.
No, I sent you the new one.
I think I got, these should be the new ones.
It isn't.
Okay. Then
Okay,
that was a mistake.
there's a cat slide that's missing. Lucy said my presentation had to have a cat slide. And it's missing. Something failed. So anyway, there's a project overview. You can run your own thing from Route Views data. And maybe get together for a BOF tonight, or a beer BOF, or whatever we call it, I forget. After this, before we head to dinner. Is that the one with the cat video? Thanks. It's not even a video. See if it works. Jeez. No, sorry, it's a major failure. I'm going to be in trouble with Lucy. That's bad. I've been hiding up in the knot, and because I'm really not that social in these things. But I know so many people here. It's really warm. So.
Now mine's not working. Yep, there. Oh. No, I got it. Thanks.
Oh. Which one is it? Yep.
Okay.
Okay, it's me again. So Tim and I and Paulo have been working on collecting BGP data using BMP under the open source project OpenBMP, as Randy and I just presented a little while ago. And during this work, we have come to realize that there are some cases where we'd like to see BMP send us more data than what is presently available. So currently, per the BMP RFC, we have access to the adjacent rib in from the router. We have access to pre and post policy. Basically, anything that the peer sends us, sends to the router where the BMP is running, we can see those updates, which is wonderful. And then we can also see after the import policies, filters, etc., have been applied. So this is what's available today in per RFC. What we'd like to do is we'd like to extend the access to the other ribs, conceptual ribs of the router. What we're recommending, we have two different drafts. In the first one, we're suggesting that BMP can also send us the local rib routes, and how that's different from the adjacency rib in post is that you may have same prefix past the import policy coming from multiple peers, but you don't really know which one is selected by the router to be installed in the local rib. Similarly, you might have some other routes that make it into the local rib, perhaps even without a BGP peering session, which we will talk a little bit about the use cases where this requirement, this need came from. Adjacency rib out is after you queue your packets to be advertised to your peers, what you are sending, especially on the edge of your network. And I'm going to let Paula and Tim talk a little bit about the use cases where these requirements sort of stemmed from.
Hi, it's Paolo. So we have divided it in local rib and edge rib out, but a little bit it's, it stands also for both of them, some of the things that we are going to say. So among the use cases, we have for the local rib, the monitor the routes selected and used by the router, right? Because we have the case of ECMP, and of course with the edge rib in, you cannot factor in all that is coming from the IGP and things like that. And so essentially you don't have reliable ECMP, or you don't have ECMP information over there. Of course, the other challenger to ECMP is, of course, also BGP hub paths, right? And I am the one that in NANOG in Bellevue 2013 was doing a presentation, PMSCCT plus Netflix, and was using ad path for precisely ECMP. But what I was saying in that presentation is that 2014 is still the year of let's say ad path, and maybe 2015 will be the one of BMP for doing precisely that. And if anybody, I would be very curious if anybody in this audience has ever used ad paths for, ECMP monitoring, and I would like to speak to you because, I found several very much challenges in doing that. So I would totally be looking forward for BMP to cover this case. The second thing is the next stop preservation. This is an easy one, I would say, and this would also apply to edge reboot, right? So it's like, the next stop changes as, we move from one table to the other. And so it would be very interesting for any sort of debugging purposes and things like that. Screen? To get, the next stop at any given point. And then, my DNA is in NetFlow IPFix because I wrote this PMSCCT collector, open source, free, whatever. And then I have the problem that with the BMP, I cannot correlate, what I get from BMP with the edge rib in with the NetFlow and the IPFix, right? And it is a little bit, bad, the situation that if you take a multi-vendor network, like the one of Entity Communications for which I work, then, you want to see what people is advertising you and you are throwing out. You want to correlate against NetFlow and the IPFix, and then you want to see also what you are advertising to the peers, right? And then you have to pick up to 3 of the 4 The four being, screen scraping, netconf, BGP, and BMP. And why instead of doing all of this, not having just, making, to use the words of one president, make BMP great, not again, but just make it great for the first time. So okay, so that's it, and then of course policy verification, right? So you have policies with BGP, so it would be nice at every stage, to verify that the policies have the accuracy, have the impact on the routes that you are expecting. And of course, the use case for Adribout, I would say, I was already mentioning it, and it's very intuitive, and that would be like, checking what you are advertising to peers. Imagine any, I don't know, even SDN solution in which you have any BGP traffic engineering. You want to close the feedback loop and see what you are actually advertising to people, so that you can modify your advertisement in a way or in another. So I will.
Yeah, and I want to highlight a little bit also.
You gotta talk
Closer
into the
to this
microphone
thing.
to make sure everybody can.
So as far as monitoring the local RIB, in the draft we do talk about how you can also do this a different way, and the current way to do it. The way to get this information, which is a major problem for us, is the locally originated data, which the current draft does talk about locally originated data. BGPLS is our biggest driving factor for this local RIB advertisement or enablement, because BGPLS has EPE, which is locally originated, but then BGPLS also distributes, and we don't want to have to use BGP peering in order to collect that data. So we want to collect the data locally from the actual device. There are other use cases where there is no BGP peering either. For instance, if you have VRFs and you have peering within VRFs, but you're not actually doing adjacency and RIB monitoring, or if you just have VRFs and you just have static routes or whatever else, it's still locally originated, so we still want to get that data to represent the routing tables for that. Unfortunately, this is cut off, so that's kind of a bummer. But the locally, okay, I have to try to move it over. Okay, yeah, so these are the changes that we've made to the draft or to update it. So one of the big things is that we want to maintain backwards compatibility, and we want to reuse the flags in the peer header. So to do that, we are introducing a new type. So it's type 3 for the peering. There is some other peer types, so we figured this would fit fine. Flags are also going to be specific to the peer type. Right now, it's not really specified if it's actually specific per peer type, since all the flags are currently used by all types, but this is very specific. We have outlined very specific flags for this particular peer type. One of them is the F flag, to indicate that the local RIB that we're actually seeing is actually going to be filtered or could be potentially filtered. So we want to know, are we getting a true state, or if we're not getting a true state? If we're not, we don't know why, but we want to know that we can't trust it. We're leveraging the existing stats. So what's interesting in the current draft is it actually says local RIB, and it doesn't specify adjacency RIB in pre versus post. It just says local RIB. So since the stats are already there, we're just going to leverage those stats. And these are per peer. So all stats are conveyed with a per peer header. We want to update or basically replace the current section 8.2 that says locally originated, since that's a little confusing. And we're pretty much doing roughly the same, taking that and building upon it and redefining it a little bit more in the local RIB draft. We also want to add another TLV for the info messages when we get the peer up message. We want to see the VRF name or the table name that the peer represents. I believe that this can actually be used for other peer types as well, even though we're calling it out in the local RIB, but there is definitely a need for us to know which peer this belongs to. We get the RD, but we don't really know what table or VRF it actually belongs to without having to pull in config data, which we don't really want to do. The second draft changes is the RIB adjacency out. This doesn't really change much except for adding a new flag, which indicates that it's adjacency in RIB, in versus out. For backwards compatibility, we're just using a new bit, and one of the bits is going to be, obviously positive for adjacency rib out, but we believe, since Paulo, myself, and we pretty much know everybody who's been implementing BMP, shouldn't have a problem with that new flag. So I think that's probably fine. We're adding new statistic types so that we can actually collect the information for the adjacency rib in, rib out. So these are the same standard types that you see now for adjacency rib in. We just want to add that for the out. So those are basically the changes that we're introducing. So, any questions?
Yeah, if there are any questions, we can discuss them now, or if you are interested in the topic, we're going to have a BOF after the session at the bar. We'd love to hear some feedback, either about the drafts or OpenBMP project.
This is Shorty Bush from INJ. There's no actual rib out, is the question.
It's a representation. So it's what's the implementation may be different.
I understand what you want.
Yeah.
I've smoked that stuff too, but when you go and measure routers, you'll find that that's why we get part of the reasons we get a ton of people fixing, so on and so forth. So be sure you specify what you really want from me.
Robert Kaszub. So looking at your use cases, I have a feeling that you not only want local RIP, but also local FIP, because those are not the same. In local RIP, you have multiple producers, which may not be the same in FIP. FIP does the local recursion in number of platforms. Plus, the route in RIP doesn't guarantee that it's in data plane, and good BGP actually advertises only what is in the data plane. So I'm not sure if local RIP versus local FIP, have you actually thought about one and the other?
We thought about it, but we didn't. Right now, we're focusing on control plane side of it. So we figured there would be more to be added if we were to actually start looking at the data plane side or the forwarding plane, because then it starts to go into the hashing as well as is exactly how certain things are being forwarded. We're using other mechanisms for monitoring that. But yeah.
John Scudder, hi. So I read both drafts, and I think they basically seem fine. I have a bunch of comments for you, but I need to translate them from Sharpie into email. So I'll get them to you in a day or two. I had one thing that I did want to bring up, though, which is in one of the two drafts, you say something about state compression, and you say, please don't do state compression. And please don't say that, because it's basically, I would be happy to try to convince you either here at the mic or later that an implementation that isn't allowed to do state compression towards BMP is basically an implementation that is required to fail if the BMP collector decides to run slowly. So I mean, I assume that your motivation for putting that sentence in there was to say, like, please don't do state compression gratuitously, which that would be fine to say, because I'm not aware of any implementations that do it gratuitously anyway.
Yeah. So we can't speak for other collectors. We do aim, though, to make sure that our collector is not the bottleneck from the router. So from that perspective, that's, for us, that's not a problem. But the users that we've been working with, or the people who consume and use OpenBMP, or people we've been talking to, especially with BGPLS or any of the IGP information, they want every event. They don't, right now it is state compressed, even with BGPLS being distributed. They want to know if the local RIB has been changed. And if it has been changed, they want to be able to monitor it. So that's why we kind of called out, if state compression was being used, I think I put in there, it was like 1 second. And that's what we've reduced BGPLS to as well, as 1 second granularity. But even then, a lot can happen, and we don't know what happened.
Right, so that 1 second thing was what had me scratching my head, which is I'm not aware of the details of everybody's implementation, but ours doesn't do anything like that at all. So I think we maybe have to have a longer conversation.
Yeah, we can define it better so that it's clearly articulated.
Right, yeah, I was planning to come to that at least at the beginning. So.
So I guess to make a comment, John, for the motivation for putting that in the draft is that as the collector, as the user, we want to get as much data as possible as fast as we can, especially if people are going to do the SDN type of implementations.
Sure, and I want you to have that, and I also want every man, woman, and child in this room to have a pony, but, you know.
Very good.
Sorry, I'm not gonna ask for Pony, but hi, Igor at Yahoo. So we've gone down this rabbit hole with a couple of vendors, and echo Robert's statement. I think what you're looking for is also local fib, because if you're looking for all possible ECMP routes, you could get a BGP view.
He stepped a little closer.
So if you are looking to get ECMP routes, which was specifically our use case, you may get the BGP view of the local routes, kind of, sort of, because you're going to get the non-recursive resolution one, and you don't actually know if the router is going to do recursive resolution or not, because depending on the implementation. Also, you don't know whether the BGP view, the local rib, says something, but then other views say do something else. You get ECMP, you still won't get the full picture with local rib.
So with that particular use case, how we've solved that, or how we look into that, is we do look at the BGP next hops, and as long as we have them unmodified, we can do BGPLS, and we can pair that together. So we can iterate through that to see the ECMP down to the next hops. We still don't have the fib. We're not saying it is either that, but we do get it. With BGPLS, we do marry that. Did you look at that? Did you look at looking at both of those together?
Yes, we have, and then you have to be bug compatible with every release of given vendor software. For example, how they're going to remarry the chip, which they may or may not, or may do it at a certain time granularity, or may not. Just saying that this is, you can't rely on local rib plus BMPLS to give you the answer. You probably will not have a choice, but end up tapping the fib. So if you're going to create a BMP fib, which we've asked at least one vendor to do, maybe you should just go for the whole thing right then and there.
But there's another draft there.
For local fib? Yeah, probably.
Okay, this working group did the original BMP work, so my assumption is that this work does belong in our working group. And I believe the authors would like this work adopted as a working group item. So maybe we just have a show of hands and who thinks this work should become a working group item. If you're in favor, please raise your hand. Yeah. If you're opposed, yeah, okay, that's sort of what we expected. Of course, as always, we'll take it to the mailing list and go from there. Is there Randy?
Randy Bush, LIJ. Doesn't this involve protocol on the wire?
Yes, so I will consult with the ADs and the IDR chairs, but we did do the original BMP spec in this working group, and there wasn't any objection. So I leave it open to discussing with the ADs and the IDR chairs, and if there's a problem, then yeah, we'll discuss it. So yeah, that's what. Yeah, so we can do the work. So yeah. Oh yeah, okay. Next one is Job.
My name is Job Snyders. I work for NTT Communications. And today I would like to present to you some work we're doing to standardize the concept of BGP session calling. Can you do the trick so the slides fit?
Not on this one, but.
We worked long and hard on these slides, and it would be a shame if there's 10% missing on the left side. Nice. We describe engineering in 3 words. It's close enough. This document outlines an approach to try and mitigate negative impact due to maintenance. And this can be maintenance either on the ISP side or the IXP side. And we'll go through 2 examples in the slides. The conceptual idea is that the BGP sessions are torn down before you do the actual work on a lower layer network. And by ensuring that BGP sessions are torn down, you give a hint to the routers and say, go start path hunting, go reconverge. Next slide, please.
You have the clicker. Does that work?
Oh, it works. Why we are undertaking this effort now? In 2014, Will Hargrave presented this idea at a RIPE working group meeting. And since then, various IXPs have used this methodology with great success. So having some years of experience in the field, we figured it's good to standardize it in a document so it becomes referenceable, and then we can promote the idea further by just pointing people at this document. In the document, we outline 2 approaches. There's voluntary teardown and involuntary teardown. Voluntary is a trivial, straightforward method that we use today everywhere, but we have not popularized it enough, in my opinion. And involuntary might be new to some of you and is a rampant layering violation. Both of these methods ensure that BGP sessions are torn down and thus the reconvergence events kick in. So if you look at a typical IXP is usually composed of multiple switches. And you connect to these switches, and over the fabric you speak BGP with each other. Now these examples also apply to the case where there is an intermediate provider between the 2 BGP speakers, such as in the case of, for instance, remote peering, or that you purchased a local loop of sorts. So we use IXP as an example, but it's really just any layer 2 environment. With voluntary session teardown, the idea is that you just type in neighbor, IP address, shutdown, enter. And this, to some of you, this is not new, to others it may be. If you look at an IXP, if the port goes down connected to your router has the interface link down event, and it can immediately start reconverging. And if you use something like BGP PIC, you might even converge quite fast. However, the guys on the other side of the fabric do not see the link going down. So from their perspective, it might take 90 to 180 seconds before they notice that the session is down, and only then they start reconverging. So by promoting the concept of shut down BGP sessions before you do work on your router will prevent certain black hole scenarios. And this is super obvious, but it's not documented anywhere. Now a more exciting example. Let's move to involuntary teardown. If on the IXP, at one of the core switches, somebody wants to do maintenance, neither side will see their interfaces go down because it's a switch in the middle. And this foot symbolizes the maintenance. So under normal circumstances, if you take no precautions and you do maintenance on that switch in the middle, then both sides will need to wait for their BGP hold timers to expire, which can take anywhere between 90 and 180 seconds. And then they'll have to start reconverging. which may or may not be fast. There are still people that use the MX80s at internet exchanges, and if you're really unlucky, it might take up to 10, 15 minutes before they're properly reconverged. So this is quite a disruptive maintenance procedure if you work in the middle. Now, with involuntary session teardown, what the IXP operator does is they deploy a layer 3, layer 4 ACL in the middle on the equipment that is about to be affected. And this ACL has as source IP address the peering LAN prefix, as destination IP addresses also the peering LAN prefix, and it matches on port 179, the BGP port. What this does is it disrupts the BGP speaker's control plane. Meanwhile, traffic, the end user traffic, is still being transited through the affected switches. And this is quite cool because ISP router A and ISP router B see their sessions go down after a while, and then they'll start reconverging, and then the IXP operator sees traffic go down on the switch, and then at some point the IXP operator can decide, well, sufficient traffic has been rerouted to alternative paths because I'm not seeing it on the switches anymore. I can proceed with the actual maintenance. And this is the layering violation because we have no way to signal from a lower layer network to a higher layer that something is about to go down. And this actually works. There are numerous internet exchange providers that do this when they do maintenance, and their customers are happy because there's no black holing. After you apply the culling, it is very important that you wait long enough. There's no fixed period of time that you should wait. It really depends on the equipment the affected parties use. So just the guidance will be to monitor traffic, and if you no longer see it go down any further, then it's the good moment to start the maintenance. So the caretaker of the fabric will need to use their judgment. We have published a 0.0 version. This is not yet a working group document, but people are acting as if it's a working group document because we've received numerous contributions and suggestions, which we are incorporating on our GitHub. If you want to go back to the original slides where this was presented, this was at RIPE 67 a number of years ago. And I'll now open up the microphone.
Linkova, someone who has been doing this for a while.
The involuntary or voluntary one?
Voluntary one. So
your microphone is not working, it seems. How many engineers do we need to fix a microphone? You want to use my microphone? Come here. Yeah.
So my question is, from my experience, in some cases, I found it more practical, instead of tearing the session down, apply filtering and stop sending and accepting any routes. Because in this case, after the maintenance is over, I can easily see if the session is up and not flapping, for example. Could you elaborate what would be better?
No, keep the microphone. Oh.
Hi.
Before you start, Jen, yes, you can indeed. There are various ways to drain traffic. The The draft hints at graceful shutdown as an example to work in a voluntary context. But what we try to capture in the document is that there's two sides. There's the operators of the routers and operators of the lower layer network. And depending on who is initiating what type of maintenance, there are various courses of actions to ensure that there is no blackholing. So you're right, this is also a valid method.
So my point is probably you should discuss on your draft. There are other ways, such as applying filters, and you can discuss that some situation it might be better. And also, to be honest, I would expect lower level provider to notify peers that they are doing something with as a link, so I can drain my traffic in advance, which I normally do, right?
Yes.
So I think it also should be best current operational practice, right? Tell your customers that you're doing something on
That
the lower level.
actually is part of the next version, that you should notify your customers if you do maintenance.
Hi, Colin Pitry, Ripe NCC. Minor comment from looking at the draft. It mostly refers to the hold timers with regard to how long before the session will come down. But I think maybe it should have a mention about graceful restart as well, and the timers involved in that, because traffic will keep forwarding even if the session has gone down for a bit longer.
Yes, we can mention, there's multiple factors involved as well, because maybe somebody has a multi-hop session or is pointing static, or so that's why I think emphasis should be placed that the caretaker needs to make a judgment call and say, now is the time. And
yes,
whatever influence it, GR or slow routers, it's somewhat irrelevant.
Sure. I mean, it's sort of covered by the part of, if you look at when the traffic has stopped as the caretaker, then everything should be fine. But it was just a comment. So.
Thank you.
So Warren Kamari, many things about this horrify me, like the fact that you need to tell people that they should probably drain BGP before unplugging stuff. It's sad, but I realize you have to. Yeah, the applying ACLs on the fabric horrifies me, but it's better than not doing it, right? These are not awesome. They're just better than the alternative. More specifically on the draft, I found some of the terminology odd, like fabric caretaker. I don't think that's well defined in the document. So you have to sort of guess at what it is, and BGP operator was also sort of a weirdly done term. So explaining terms a bit better and who the actors are, I think would make it way easier to read.
I understand where you're coming from, but since there are 2 points of view, the operator of the lower layer network and the operator of the BGP speaking network, we figured that if we call everything operator, it might confuse people. So maybe it's too creative.
No, it's a good thing. I just don't think you actually define what caretaker is anywhere. Like if you had a terminology section that said what you mean, that would make it way simpler.
Okay, thank you.
Rüdiger Volk, Deutsche Telekom. I wonder, as a user of a switching fabric, as a client, I usually would consider doing BFD to make sure that whatever and whoever makes the switching fabric non-functional for my particular destination, to get the signaling back to the BGP that, well, okay, it's gone.
Absolutely. And this does not preclude the use of BFE, to be clear. But there are scenarios where BFD may not be available for whatever reason, and in those situations, this technology is useful. But
I can have an example.
Okay. Yeah. Well, okay. Kind of the involuntary thing. Actually, the layer violation kind of disturbs the BFD functioning, right?
I don't think it does.
Oh, sure. You block out certain traffic where the blockage is not available to the BFD.
But the session will go down, so the goal is accomplished. The goal is to prevent the negative impact of maintenance. And
Yeah, so to sort of clarify, the example where BFD doesn't work.
who are you?
Joel Yegley. The example where BFD doesn't work for you is when you're on a multilateral exchange and the maintenance is actually occurring not on the switch that you're on, but the switch that your peer who's attached to also to the same route server is on. And so that doesn't happen to Rudiger because he doesn't peer in that fashion. But it does happen, problem solved. Yeah, there are perfectly good reasons to not do it that way. And some of us, in fact, prefer to not do it that way, but that is separate from the case where that actually happens. I think one of the things that the draft like points to me or points me at is the fact that this is actually somewhat hard to do in some router platforms. And it's not that we want to get into the nitty-gritty details of interface design, but in fact this is two configuration changes on some router platforms, whereas in others it's a state change, which is I'm going to turn off this BGP session, but without changing the config, right? And that's actually kind of a different behavior, much like graceful restart, which is actually sort of the psychopathic approach to this, which is I'll be right back. So hold on to these routes until you invalidate the next hop. Right?
Sayonara, you take care of this.
See you later. Like so that's like the opposite approach, right? But you could imagine, and we have an automation system that does this, so I don't have to imagine it. That the process of reloading the router actually drops the eBGP sessions first, and then your iBGP ones, and then it hangs up and reloads, which is pretty much what we do. But like we have a robot that does that for us, so that the human doesn't have to make 3 configuration changes and then unroll them in reverse when the router comes back up, because you don't want it to come up broken and start forwarding again either.
Yep.
Robert Ashuk. So I like the idea about TCP port blocking, but as you know, distributed IXs are the networks on its own. So they run their own IGP, they run VPLS, they run VXLAN, what have you. So maybe it's a good idea to augment your draft to actually cover more of the real distributed IXs and provide provide of how big the ACL may be required in that case.
Because it's no longer understand what you're saying.
When you're running distributed IX and you want to apply ACL on your switch, it's no longer IPTCP packet of the customer because they're embedded within the VPLS, within VXLAN, what encapsulation the IX operator chooses. And you are lucky if it's not encrypted.
So there are a number of ways to skin the cat in that regard. And it's very IXP deployment topology dependent. So what the draft does, it does provide a few configuration examples that are applicable to a few types of hardware and software. On an internet exchange, you could apply if it's a core switch and your hardware will need to support to apply the ACL inside the VPLS instance or inside the VXLAN thing. But maybe you're just doing maintenance on an edge switch, which means you can deploy it directly on the ports of the affected members. That's your problem. Just drop the packets somehow. And if you have to do it manually, I would consider it somewhat out of scope for this specific draft, because today we use VXLAN, maybe tomorrow MPLS is popular again, maybe the day after we have plain layer 2 switching. That's somewhat of a moving target. But conceptually, making sure that the BGP sessions that run within that fabric, that they are somehow disrupted, that is what this draft is about. So yes, the draft should work for distributed internet exchanges, but it should not be, I don't think we need to go into the weeds explaining how to do that exactly. Any more questions? My co-author, Matt Griswold, is standing over there. This is his first IETF. Say hi to him. I have asked the chairs for working group adoption a few days ago. I'm not sure on the dates, but I think there's ample of time for everyone to chime in and say whether they want to adopt this or whether they hate the idea and it should burn in a fire. So far, feedback has been positive. So if you really disagree with this idea, now is a good time to speak up.
Okay, thank you. I think there was enough interest on the mailing list. We'll do, I think we haven't done an official call for adoption. We'll do that and go from there. With that, that's the end of our agenda. Thank you very much, and we'll see you in Prague, I guess. Huh? Oh, you already did. Oh, it's all right. Okay. I thought, yeah, you got. You already called. Yeah. I thought you.
I did too.
Where's the remote? So what? I couldn't understand your.
That's okay. You got me mid.
Did we need to talk about it, or is there any debate on PMP stuff?
There's a whole big thing.
Is it a longer discussion, or?
I'm not, yeah, I just